Okay, so hello everyone. Can you hear me? Hello.
Yes, sir.
Okay. So just we are waiting 2 minutes, then we will continue our today's class. Just waiting for 2 minutes. Okay, so let's go to today's class. So basically today is our third number of class. And mainly today I will try to discuss about the topic how you can easily make the normalized difference water index, mainly NDWI, and identify the water on the surface. And we are also trying to identify the two season such as wet season as well as also summer season. And we also use here the Sentinel 2 satellite imagery. Okay, so let's go to today's class. Just I simply try to share my screen. Okay, so now can you see my screen? Okay, can you see my screen now?
No, sir.
Okay, now it's sharing. Yeah, it's sharing. Yeah. Yes. Okay, so let's go. Okay, so basically today is our third day. Mainly today I will try to discuss about the how you can easily filtering and displaying the satellite images, mainly Sentinel-2 satellite images. And after this, how you can easily use the Sentinel-2 satellite imagery and then monitor the NDWI, normalized difference water index. How you can easily do this for the different region. And then we also try to discuss about the NDWI time series chart. How you can easily make the normalized difference vegetation index time series chart over a period of time. And then how you can easily export any shape file from the Google Earth Engine platform. We also try to discuss about the calculating any indices from the satellite images. So any satellite image, it can be Landsat, Sentinel, doesn't matter. How you can easily calculate any types of indices. It can be NDWI, NDWI, EVI, VCI, TC, any other indices how you can easily do. And how to add the gradient legend and how you can easily make the land surface temperature monitoring using the MODIS or Landsat, and then NDWI calculated from MODIS and Landsat data. So let's go. So first of all, you can see filtering and visualizing the satellite images. So previous class, I also tried to discuss about that Landsat 8 satellite imagery, how you can easily filtering the Landsat 8 satellite imagery. And in this time, when you want to filter the Sentinel 2 satellite imagery, we also try to focus the same process. Okay, so mainly filtering, it depends on the some factor. First factor is that your region. Your region can be anything. It can be Dhaka city, it can be Kolkata city, any types of region. It can be anything. Okay, so first of all, you have to import your shape file in Google Earth Engine platform. Suppose you want to need the Sentinel-2 satellite imagery for the Dhaka city. So you can simply import your shape file in Dhaka city. Then you also need to filter the images according to the image properties. Suppose I want to need only for those images, which image will be not more than 1% cloud cover. So I want to select only 1%, less than 1% cloud cover, and then make this filter. And suppose in this time I want to need only for this image for year of 2017 or any specific season, rainy season, wet season. So any time period, you can simply filter your date. Okay, so mainly when you want to filter Landsat or Sentinel, we always follow the three factors. First factor is that your region. Second factor is your image metadata or image properties. Third factor is that image specific time period. Okay, then we can easily filter any satellite imagery. So let's go. So mainly today I will try to discuss about the Sentinel-2 satellite imagery. So just I simply search here on the top of the code editor. I simply search here. Suppose I search here the Sentinel-2. Sentinel-2 I simply search. So here I can get the Sentinel-2 multispectral instrument level 1C. I simply click on here. I want to use this multispectral instrument for level 1C. Here I can get all of the information about this satellite images. Okay, mainly this satellite image availability time period you can see. We can get the satellite image for year of 2015 0623 from present time. And this dataset provider is the European Union, and this is the unique ID of this image collection. Okay, and also you can see the all of the band in here of this dataset, image properties. Okay, so in this time I want to work with this satellite images. So first of all, I simply import the satellite images in my code editor. I simply import. So now you can see this image collection of Sentinel-2 multispectral instrument is imported in my code editor. Here you can see the default variable name. It's showing as the image collection. Okay, so if you want, you can change it or not. It's totally depend on you. But as a variable name, you can put anything in here. So just I simply put the name, suppose Sentinel-2. You can put any name, no problem. In this time, I need to filter this Sentinel-2 satellite imagery for the different 2 time period. Suppose rainy season as well as also dry season. Okay, so I have to filter the satellite images different 2 time period. So first of all, I simply filtered this image collection for the dry season. So I simply put a variable name, suppose image dry. You can put any variable name. And then I just simply call my full image collection Sentinel-2. In this time, I also need to use here the filter bounds function. Okay, so which area you want to need this Sentinel-2 satellite imagery, you also mention in here. In this time, I simply go to the asset tab. Suppose I want to need the satellite image for the Dhaka city region. So just I simply click on, you can see Dhaka city. I simply put this shapefile. This is the Dhaka city shapefile. I simply import. Now this shapefile is imported in my code editor. I just simply change the name. Suppose I put the name such as ROI. Okay, you can put any name. In this time, Sentinel-2, this is the one variable. It is a whole image collection of Sentinel-2 satellite imagery for the whole world. But in this time, I want to need this satellite image for the only for the specific region, such as Dhaka city. And Dhaka city, you can see Dhaka city shapefile is stored in a variable ROI. Okay, just I simply use here the ROI. I simply mention this variable name ROI. So in this time, I can get only for this image, which images are available only for the Dhaka city. I want to check how many images are available for the Dhaka city. Sentinel-2 multispectral instrument, I want to check how many images are available. Just I simply copy this variable name and paste here and use here the size function and click to the run. So now I can see how many images are available only for the Dhaka city region. 865 images are available. Okay. This 865, what is the duration of this image? This duration is that year of 2015 to present time. Okay. This is the duration of the satellite images. Suppose in this time, I want to need only for the dry season. I want to need this satellite image only for the dry season. Okay. So just I simply put here the another function. It's called the filter bounds function. Sorry, filter date function. I simply use a filter date and put here my specific start date and end date. In this time, I want to observe the NDWI year of 2022 or 2020, any time period. So 2020, suppose dry season. I simply put here year of 2020 for the dry season. Start with January from, I simply put here this 2020. Suppose April 30. Okay. So mainly this is the dry season in Bangladesh. I simply put this dry season period in here. In this time, I want to check how many images are available for the dry season. Just click to the run. So now you can see I can get For the dry season, only for the 48 satellite images. Okay. So in this time, this 48 satellite images, it has a lot of cloud covered image, less than 1%, 2%, 3%. All of the images are available in this image. But in this time, I want to need only for this image, which image will be not more than 1% cloud cover. I want to need only for this. Okay. So when you want to filter the image properties or image metadata, then we need to use here the filter metadata function. I simply use here the filter metadata, and here I can get all of the argument, name, operator, and value. What is the name? Name is that image properties. Image properties, lot of image properties we can get from here. You can see. If you want, you can also use the other image properties for filtering. In this time, I want to use here the CloudPixel per sentence. So I simply copy the CloudPixel per sentence and paste here. It is a string. You must be use here the quotation and then put this name. An operator, I just simply select the operator such as less than. Less than. Suppose I want to need less than 1. Okay. Okay, now I want to check how many images are available less than 1% cloud cover in Dhaka city in the summer season. I want to check it. So just I simply click to the run. Now I can get, you can see it will 20 images. Okay, this 20 images is available in the Dhaka city in the summer season. It is the less than 1% cloud cover. Okay, so in this time, instead of the filter dates metadata function, we can also use here another function. It's called the short function. Short. Mainly short is another function. When you want to shorting a specific any properties, then we are also using the short. Short, it also filtered the image properties. In this time, I want to short according to the CloudPixel per sentence. I simply paste in here. Okay. And then I just simply use here the false function. False. Now I want to check how many images I need to get. In this time, we can get also more images. You can see 48 images we can get. Okay. When I want to use here the short according to the CloudPixel per sentence. Here I can get total of 48 images. I want to use all of the images and make a composite. So I simply use here the mosaic function. I simply use here the mosaic and make a one composite. And then I try to show this result. I simply also need to use here the clip function because I want to need the result only for the region of Dhaka city. Dhaka city is stored in the ROI. And then I simply show the display the image. I simply use here the map.add layer. And my object name is that image. Right. And click to the run. So now one layer will be added, but I did not see my region. In this time, I want to focus the shapefile of Dhaka city. Just I simply use here the map.center object, and then call the ROI and put here the zoom level 10 and click to the run. So now it also focus my center of the Dhaka city. Now you can say I can get the result look like this. So in this time, this image is look like this because I did not add any visualization in here. Okay, so in this time I need to add here the visualization. For adding the visualization, I just simply click on here and add here the subsignet the band 4, band 3 and band 2 true color composite, and then I simply increasing the range, stress 98% for better looking, and apply. So now you can see we can get this very better image for the Dhaka city Sentinel 2 satellite imagery. Okay, so it's image mainly dry season image we can get in here. Okay, so in this time, suppose I want to need the another season image, suppose rainy season image. So in this time, I can simply import this visualization parameter in here. You can see a new line code will be added in here. I just simply copy this visualization parameter from here and paste after the object name. Okay, now this visualization is set it with my code. Okay, so in this time, I also need the another image for rainy season or wet season. I also put the layer name. Suppose this layer name is that dry image. Okay, so now it's set it. You can see all of the visualization which I added in here, it automatically set it, and also you can see layer name also set it in here. So in this time, I want to need the another satellite images such as wet season image. I want to need. Okay, so for this, I just simply copy the same code from here. I simply copy the same code and then paste in here. And first of all, I simply change the time period. In this time, I set the time period according to the wet season. So I simply put here this wet season. It will be start from perspective of Bangladesh June. From I can put here the such as October. Suppose October. I randomly put this time October. Okay, and then all of the things will be same. And I want to show the result. I simply use that the map dot add layer. And also need to change the variable name. I simply change the name, suppose image wet season. Okay, then simply copy this variable name and paste here and click to the run. So now we can get the another image in the wet season year of 2020. Okay, I also need to add here the visualization. So just I simply click on here and add here such as band 4, band 3 and band 2, and then simply increase the 98% for better looking and then apply. Okay, in this time here you can see when I use this image in the dry season or rainy season, here I can find out some cloud on the satellite images. Okay, but in Google Earth Engine platform, we can easily remove all of the cloud and haze from the satellite image and then get very clear satellite images for any time period. Okay, so just I simply import this and simply copy and then simply paste after the object name and then use here, suppose it is the wet image. Okay, then click to the run. So now it will also set it. We can get the 2 time period image, dry season image and wet season image. You can see this is the dry season image, that is the no cloud, and this is the wet season image. In the wet season image, we cannot find out some cloud. Okay, but we can easily remove cloud and haze from the satellite images and get the very clear satellite images. Okay, so in this time I will not showing this part. I also try to showing this part next class, how you can easily remove the cloud and haze from the satellite images. So mainly cloud is very hampered when you want to make the land use land cover classification map. Suppose in this time you want to use this image and then make the land use land cover classification map. Then this CloudPixel value also mixing with build up area or barren land, then our classified result is not good. Okay, so mainly when you want to use the land use land cover classification map, you want to must be remove all of the other pixel values such as cloud shadow, this type of pixel value you need to remove. Then you can get the clear satellite image and use this satellite image for making the land use land cover classification map. So in this time, we are not using the land use land cover classification map. We can just showing that how we can easily make the NDWI or normalized difference water index for the different 2 season, wet season and dry season. Okay, and then identify the water pixel value on the Dhaka city surface. Okay, so mainly when you want to calculate the NDWI, we first of all we should know what is the formula of the NDWI. NDWI formula is that I can simulate the formula. Formula is that we can write the formula such as this is the green band minus near infrared band divided by green plus near infrared band. Okay, so this is our formula. In this time we are using the formula and then try to calculate the NDWI for the dry season as well as also wet season or rainy season. Okay, so let's go. So first of all, I just simply take a variable. Suppose I simply put the variable name is that NDWI dry. Okay, in this time I want to make the NDWI for the dry season. So just I simply call the dry season image. So this is the dry season image. I simply copy and this variable name and paste here. Okay, and then I just simply use here the different way. So if you want, you can use here the more than 3 or 5 way for calculating this type of indices. So in this time I show you the very easiest way. This way is that you can simply use a function. This function is the normalized difference. So this is the normalized difference. It's a built-in function. This function is already built in Google Earth Engine server. Mainly this function computed the result such as green minus near infrared divided by green plus near infrared. Okay, so it automatically calculated this result. If you want to know the more details about this function, simply copy this function and then paste in the doc tab. Then you can get also more details. You can see it's a built-in function. It computes the normalized difference between two band. When you want to calculate any normalized difference within any two band, then you can use here the normalized difference this function. Okay, and it computed as first minus second band divided by first band plus second band. Okay, so when you want to just simply put the band name. Okay, so in this time I simply use here the normalized difference function, and I simply put here mention my band name, which band I want to calculate it, the normalized difference. I want to calculate it the normalized difference between green and near infrared band. So I want to find out the green and near infrared band. From here you can see what is the band name. So here I can get the band name. Green band name is the B3, and near infrared band you can see B8. Okay, B3 and B8. So in this time I just simply put here the B3 and also put here the B8. Okay, so I simply select the B3 and B8. So now it calculated the NDWI. Okay, and mainly this is the normalized difference function. It computed as B3 minus B8 divided by B3 plus B8. Okay, in this time I also take the simply copy the same code and then try to calculate the NDWI for the weight season. I simply change the name, suppose NDWI weight, and also call the weight season image weight. Simply copy and then paste here. Okay, so now I also calculated the NDWI for the weight season. So now I want to show this map in here, display on the map. So for this I just simply use the map dot add layer function and then simply call the NDWI dry. Okay, and then I want to show the result such as I simply use this, suppose make a dictionary and put here the mean. It will be start from such as -1. I use the max such as 0.5. You can also put at the 1. There is no problem. Okay, I want to show the result in this time in this range. Okay, then I also use here the plated function for showing the different types of colors, such as I simply put the color such as red. Then also use here the suppose yellow. Then use here the green color. Then green color, and we use here the blue color. Okay, and also put the layer name. Suppose this is the NDWI dry. Okay, and also put the same code again. Simply copy and paste in here, and then simply call this image NDWI weight and paste here. Okay, then all of the things will be same. I simply change this name. Suppose NDWI. This is the weight. Okay, and click on the run. So now we can get also another two layer, NDWI dry season and NDWI season. So okay, so what's the problem? Okay, I use here the double. Okay, I use here the double square bracket. I simply remove. Now I hope it will be work. So we can get here the total 4 layer. Okay, now it will be loaded. Here you can get total 4 layer. Okay, NDWI wet image, NDWI dry season image, wet image, and dry season image. So it will be loaded. We can find out the lot of water pixel value in the rainy season or wet season than dry season image. Okay, here you can see these are the, now it represented this map is that NWI map of wet season or rainy season. Here you can see there are a lot of water pixel value we can find out in the rainy season. But when I want to open the dry season, you can see very little. Okay, this is a dry season image. You can see very little water we can get in here on the surface. But when I want to use the NDWI wet, you can see there are a lot of water pixel value we can find out in the wet season, rainy season image in the satellite images. Okay, also you can see, and now you can easily export all of the maps. Suppose you want to export these satellite images, you want to export the wet season images, you want to export the NDWI for the dry season, as well as you want to export the NDWI wet season. Okay, so you can easily export all of the map, and final map we can easily create it in ArcMap software for our research paper or our presentation work. Okay, so now I need to check the pixel value. You can see, you can simply check the pixel value. Suppose in Explorer tab and clicking on the any water pixel value. So mainly NDWI we can get the high pixel value. You can see negative, high positive value identify the water. Okay, we can check. You can see we can get this. Okay. So you can see samples in this time the same coordinate. You can see the same coordinate we can get in the wet season. We can find out the water. But dry season, there is the no water. We can get the negative pixel value, the same coordinate also. Okay. So I have to check the another place. Now I can get for the coordinate. It will be loading. Okay. So you can see in the NDWI dry season, we can get there is the no water for the dry season, but in NDWI wet season we can get the water. Okay, in this place same coordinate. Okay, so in this time we can easily find out water pixel value for the different time period using the NDWI. So in this time we are using here the Sentinel 2 satellite imagery and then try to make the NDWI using the Sentinel 2 satellite imagery and then make the NDWI map for the different season, wet season, dry season, or any time period. You can easily put and then you can easily get the result. Okay, and final output you can easily export as a TIP images and make the map in ArcMap software. Not only for the NDWI, any types of indices. Suppose you want to need the result for NDVI, just you can simply put the name. Since suppose for the NDVI, what is the NDVI? NDVI is that NDVI formula is that near infrared minus red infrared minus near infrared divided by red infrared plus near infrared. Okay, just you can simply change here this band value. Then you can also automatically calculate the NDVI map also. And final output you can easily make as a TIP format and make the map in ArcMap software. Okay, so in this time anyone any question in here you can ask me any question in this code for creating the NDWI for the different season. Any question in here? Anyone?
Hello.
Yeah, please.
Sir, can you explain the SQRT function? Which one you use after dot something? SQRT. Sir, please open your code.
Okay, so
I will tell you.
yeah.
Sir, this one, this SQRT. From top. Sir, please go up.
Yeah,
This one SQRT cloud pixel percentage, cloud pixel percentage, comma false. What is the meaning of false here?
In this time you can see when I want to use here the false cloud pixel this short in the short we can use here the cloud pixel percentage and use here the false. False means that in this time it shorting and removing all of the cloud pixel value. Okay, CloudPixel, all of the CloudPixel, it will be removed when I want to use the false. If I don't use the false, we can also exist all of the CloudPixel also in the satellite images. Okay, so when I want to use the false, mainly false and true, these are two boolean operator. When I want to use the false, it means that in CloudPixel percentage, all of the cloudy pixel, it will be removed. Or when it's a true, then it will be exist. Okay, so mainly when I want to use the false, then it will be removed, all of the cloudy pixel. Without false, you can also try to run the code. You can get the some lot of cloud in your satellite images. Okay, so mainly in this time, I sorting according to the CloudPixel percentage and then remove all of the CloudPixel percentage. That's why I use here the false function in here. Yeah. Okay.
Yes,
Any
sir.
question? Any question?
So here basically here no cloud percent has been considered in this
Yeah.
false function.
According to sorting, we can use do it. Yeah.
Sir, I have a doubt.
Well, sir, NDWI formula I think wrong. Near infrared minus rate
Oh
divided
yeah.
by near infrared plus rate.
Yeah. This formula is the near. Yeah. Near minus red. Just you can put this, then you can also get the near NDWI result. So yeah, thank you. Yeah, please. Any question?
Sir, I have a doubt.
Yeah, please.
Sir, in that first one, when we are using that like above one, that when we are this one, that Sentinel 2 dot filter bounds bracket, you already put ROI. Then
Yeah.
again you're using that dot clip bracket ROI. What's the difference between this?
Yeah. Okay. So basically, filter bounds, it is a function. This function is mainly intersecting with your whole image collection in your region of interest. Okay. In this time, Sentinel 2, how many images are available for your region? Okay. So mainly we can get the satellite image as a tiles. How many tiles are available in your region? We can find out according to the filter bound function. How many tiles are available? Okay. And then when I want to clip, it will be just max only for my region. Okay. So filter bounds is a function. It's mainly intersecting with all of collection in Sentinel 2, which are available in my region. And when I want to use the clip function, it's just clipping according to my region. You can see when I want to just show the result without clip function, then I can get the result as a tiles. All of the tiles make a tiles. You can see, you can easily get for the image dry season. I simply open. You can see,
Now
I can get a tiles. But when I want to clip these tiles in my shape file, I can get it only for my region of Dhaka city.
Okay, sir, now understood. Thank you.
Okay, any question? Okay. So now you can easily export the satellite images and work with the ArcMap software or QGIS software for making this map layout for your research for other things. So it's very easy.